Okay, so let's just backtrack slightly. Momentum has a symbol P. It is mass times velocity. Velocity is a vector, so it has direction. If it's moving to the right, it is positive. If it's moving to the left, it's negative. And the law of conservation of momentum, whatever momentum is the start, it's the same at the end. So let's do one of my favorites. Boys being stupid. All right, we do stupid things. So there was this, I remember teaching this when YouTube was brand new. I think YouTube was only about a year out. So this guy was holding out a rifle, and he had a stupid look on his face, which was like, watch me, I can hold this rifle as I fire it. And he did. And when he fired it, it recoiled, moved back, and broke his nose. And it was hysterical. And the question is, why? Why does that happen? So, imagine you've got a bullet. I love my eye diagram. Imagine you've got a bullet in here. And the bullet has a mass of 0.1 kilograms. Right? I'm not going to do anything fancy with units and stuff. Okay? So the bullet has a mass. Let's write this here nice and neatly. Bullet. Okay. Bullet has a mass of 0.1 kilograms. Right? And is moving with a velocity of 1,000 meters per second. All right. So there's two bits of information given. I'm going to read the third one. The gun has a mass of 10 kilograms. All right. Explain what happens. Okay. So now, if you don't understand something, put your hand up, drop me a comment, make it go bing, and So at the start, before he fires the gun, this is really important, the momentum is 0 at the start because nothing is moving. He hasn't fired anything. Okay. So once he fires the gun, so after firing the gun, right, the bullet has a momentum equals mass times velocity. His mass is 0.1 kilograms. His velocity is 1,000 meters per second. So his momentum is 100 kilograms meters per second. That's the units, but let's not worry about the units quite yet. The problem we've got is the conservation momentum says wherever it is at the start, it must be at the end. So the bullet has a momentum of 100 kilogram meters per second. But it's got to be 0. It can't change. So if the bullet has a momentum in this direction of 100 kilograms meters per second, well, the gun, oopsie daisy, I put that in the wrong place. The gun has the opposite momentum of minus 100 kilograms meters per second. They've got to add up to 0. That is the law of conservation of momentum. It cannot change. If the bullet suddenly has got 100 kilograms meters per second, then the rifle must have it in the opposite direction. So the momentum equals mass times velocity. Let's write underneath and B. So this we're going to talk about the bullet. And this we're going to talk about the rifle. The momentum of the rifle is minus 100 kilograms meters per second. We know its mass is 10 kilograms. Okay? But we don't know its velocity. We also know, and I've got this from the equation, the formula momentum equals mass times velocity. I can work out its velocity by rearranging this to minus 100 that's not 100. Minus 100 divided by 10, and that'll give me the velocity. So the velocity is minus 10 meters per second. The minus tells me it's moving to my left. So the gun moves to the left at a velocity of 10 meters per second, smacks the dude in the nose and breaks his nose. Does that make sense? That's a lot of information I've thrown at you. All right, let me